Have you ever just stopped and really wondered what a thought is? I mean, seriously, what is it made of? How does your brain take a flicker of light, a memory, a sound, and somehow weave it all into a single, coherent idea? Well, we're going to dive into that because the answer is way cooler and more dynamic than you probably think.
You know, for the longest time, the simple picture of the brain was like a one-way street. Information comes in through your senses, your brain processes it, and then a command goes out to your muscles. You see a ball, you catch a ball. Seems logical, right? Well, it turns out that simple, linear model is just completely wrong.
The reality is so much more interesting. It's less of a one-way street and more of a complex biological freeway system, with loops and interchanges everywhere. Your motor areas are constantly talking back to your sensory areas. It's this non-stop, dynamic recycling of information, a constant conversation that is literally building your reality second by second. And this isn't just a fun theory. Get this. The actual neuroanatomy shows that over 80% of the connections between different areas in your cortex are two-way streets. This isn't some quirky feature, it's the fundamental design principle of how we're wired. So feedback isn't the exception, it's the rule.
Now, there's a scientific term for this whole process, for the very act of thinking itself. It's called mentation. It's basically the magic of taking all these recycled little bits of information, these unfolding memory units, and seamlessly integrating them into what we experience as a coherent thought.
So how does the brain manage all this chaotic recycling without it just becoming noise? Well, it does it through this really beautiful layered structure. You can think of it as 4 distinct, but totally interconnected, tiers of connections. Each tier builds on the one before it, taking us from a simple reflex all the way to a complex, abstract idea.
So here's our roadmap. We're literally going to build a thought from the ground up. We'll start with the most basic, the short reciprocal loops. Then we'll layer on the association loops, then the really powerful prefrontal-hippocampal loops, and finally, we'll look at the subcortical modulatory loops that kind of fine-tune the whole operation.
All right, let's start at the very bottom with the foundation. These are the first 2 tiers, the absolute bedrock of how we perceive the world moment to moment.
Tier 1 loops are the fastest, the most fundamental. This is your brain's immediate reaction system. Think about touching a hot stove, that lightning-fast reflex where you pull your hand away before you've even consciously processed the word hot or pain. That's a Tier 1 loop in action. It's raw sensory data recycled directly into a motor command.
And the science on this is rock solid. We already saw that 80% number from Fellman and Van Essen, which shows how common these connections are. But it's more than just reflexes. Researchers like Lame and Rolf Sima have shown that this constant, recurrent processing is absolutely essential for even the most basic conscious perception of the world around you.
Okay, now let's build on that with Tier 2, the association loops. If Tier 1 is about raw data, Tier 2 is about making sense of it. These loops are what take all the scattered features of something, its shape, its color, its sound, and bind them together into a single coherent object. This is how you see a face, not just a random jumble of eyes, a nose, and a mouth.
And what's amazing is we can actually see this happening in the brain. Landmark studies by Singer and Gray found that a specific kind of brainwave called gamma band synchrony acts almost like a temporary glue. It synchronizes neurons in different parts of the brain, basically telling them, hey, you're all working on the same object right now. And even cooler, work by Fries and others showed that when you focus your attention on something, you are actively boosting this gamma synchrony. Your focus literally helps build the world you perceive. Okay, so we've got reflexes and we've got objects. This is where things get really, really interesting. This is the human upgrade, the tiers that give us our unique cognitive superpowers. Welcome to Tier 3. These loops connect the prefrontal cortex, your brain's CEO, with the hippocampus, your memory center, and together they are the engine of narrative. This is the system that lets us break free from the present moment. It's our brain's time machine, letting us travel back to remember yesterday and jump forward to plan for tomorrow. And the mechanism for this is just beautiful. Studies show that a slow brain wave from the hippocampus, a theta rhythm, acts like this big, slow carrier wave, and riding right on top of it are these rapid-fire bursts of gamma waves from the prefrontal cortex. This theta-gamma coupling is an incredibly precise way to route the right memories and plans to the right place at exactly the right time. And finally, we get to Tier 4. Now this one's a little different. It doesn't create thoughts in the same way. Instead, think of it as the brain's master tuning system, or maybe its emotional core. These deep loops add the color, the drive, and the motivation to our thoughts. This is what makes the difference between just noticing a flower and feeling a sense of awe and wonder about it.
The evidence here is just massive. You've got the basal ganglia, which helps select which thoughts and actions get prioritized. You've got the cerebellum, which we used to think was just for motor control, but we now know is crucial for cognitive timing and prediction. And of course, you have the famous dopamine system, with neurons that are constantly calculating what's worth paying attention to, shaping our motivation from the ground up.
So, we have these 4 distinct tiers, but the real magic, the very essence of a deep thought, isn't found in any single one of them. It's all about how they work together, in harmony. This is the absolute key insight. Deeper thinking isn't just about adding more layers. The research puts it perfectly. It arises from nested oscillations that recruit multiple recycling levels into synchrony. So what does that mean in plain English? It means a deep thought isn't a stack of bricks, it's a symphony.
Let's just break that down. If only Tier 1 is dominant, you get a simple reflexive thought, a gut reaction. Now engage Tiers 1 and 2 in synchrony, and suddenly you have a coherent perception of an object. Bring Tier 3 into the orchestra, and now you can weave a story about that object, remember its past, plan for its future. And all the while, Tier 4 is the conductor, modulating the entire performance, deciding how important or exciting or even scary that thought should be.
Okay, so this is a really elegant model of the mind. But what does it actually tell us about the world? Why does any of this matter?
Well, for one thing, it gives us a really powerful way to think about the differences between different kinds of minds. A lot of animal cognition is a brilliant mastery of Tiers 1 and 2, producing these incredibly fast, effective thoughts about the immediate environment. What seems to make human thoughts so different is our ability to get Tiers 2, 3, and 4 locked in this deep recursive synchrony. And that's what unlocks abstract language, long-term planning, and creativity.
This model also helps us understand other states of mind. I mean, think about creativity. You could see it as this flexible, masterful synchrony of those higher tiers, allowing you to remix old concepts in new ways. Or what about dreams? You know, those weird, fragmented dreams with random images? That could be your lower tiers firing away without the higher ones to organize them. But when you have a full, story-like dream, that's a sign the whole orchestra is starting to come online.
So to bring it all back to that very first question, what is a thought? It's not a thing at all. It's a performance. It is a symphony. And the richness, the depth, the beauty of the music is determined entirely by how many sections of the orchestra, how many of these recycling tiers are all playing together in perfect time.
Which leaves us with one final and pretty crucial question. If a healthy, creative thought is a perfectly conducted symphony of synchronized brain loops, what happens when the instruments start to fall out of tune? What does that tell us about mental health, about brain fog, about the very nature of our consciousness? Something to think about.